we are going to see that how these stacks are represented as a data structures. We will see how we can implement this stack using different techniques. Then array representation of stacks. So in the computer's memory, stacks can be represented as a linear array. As we have discussed that to implement the stack, we need to use either array, and array is a linear collection of elements. Every stack has a variable top. So here we will use one variable whose name is actually top. We are calling it as a top, and which is basically pointing to the top element of the stack. Now top is actually a position where you can add the element or you can delete the element. We will also use another variable called max, which is actually signifies what is the maximum size of your stack. We have to use this uh, max value when we are doing the push operation. So we'll see the later slides that how we can use this variable to get our task done. Here we are using two terms, underflow and overflow. So underflow is basically deals with the pop operation, and overflow deals with the push operation. So push means insert, or you can say add, and pop means delete. Now how we are going to use this underflow and overflow? So whenever you are going to make a pop operation, means you want to delete something. Now deletion is only possible when there exists an element. Let's say you have an empty stack and you are asked to do delete operation, then it is not possible because there is no element existing. How can you delete the element? So before performing any operation of pop, we first need to check that underflow is existing or not. Means we want to check that the stack is empty or not. So if top equals to null, we say that actually the stack is underflow. There is no element existing. So when I say top equals to null, this we are using in case of linked list implementation. Otherwise we are checking that if top equals to -1, that means this is underflow condition and it means that the stack is empty. Similarly, if you find top equals to max -1, this is for overflow. This is used when you are pushing the element. So if top reaches to the max -1 value, that means your stack is full. What does it mean? It means max -1 means max is a maximum size, and because we are using array to implement it, the maximum value will be max -1. It means if I have an array of size 6, that means I have value from 0 to 5. If my array is of size 6, then it will go from 0 to 5, that is this is max -1. So if your top is already max -1, that means you already occupied all the positions of the stack, all the place of the stack, all the space of the stack, and you are not allowed to insert any more element. So we always check the overflow condition when we do push operation, and we check underflow when we do the pop operation. Let us have a look about the push and pop operation. So this is your overflow. As I said, overflow we check for the push operation. So if top equals to max -1 means your stack is already full, and you will say overflow and you will go to step 4, that is end. Otherwise what you will do, you will increment the top value. Top will be top +1, and you will insert the value into that index. So we are calling our array as a stack. So this is our array which is now to be worked only this. We cannot allowed to insert element at any index. Whenever you have to insert the element, you have to go through this procedure, and if array behaves this, if the array fulfill this procedure, then it is said to be the uh, stack, means you are able to implement the push operation of the stack. So how it will work? So let's say if you want to insert any value, you will call a push operation. If you want to insert let's say 3 value, and we assume this is a scenario. So let's say we have already one value inside it, 2 here, and always we point it by the one pointer, that is top. That points, actually it's a variable that points to the topmost element. So if you want to insert value 3, what it will happen, you actually go here, set top equal to top +1. So top +1 means now top will point to here, top will point to here, and you have to insert the value into this stack of top. We are calling this as a stack. Okay, and then you will insert this value, so 3 will be inserted here. Here when we implement the stack with the help of array, we assume that initially top equals to -1. What does that mean? It means your stack is empty and your top is -1. That means you are going to insert your first value. Let's say it's the same case. If you want to apply the push operation to an empty stack, what will happen? It will first increment the top, so top becomes top plus 1, that is top equals to 0. It points to this position, that is the first index, and here you can write the value. This is how the push operation can be performed in the stack. Then let's talk about the pop operation. Pop operation refers to the delete operation. So whenever you delete, you need to check the underflow, already we discussed. So if top equals to null, or you can say when we are, because we are implementing using an array, so with the array we actually use -1. So if top equals to -1, that means there is no element existing in the stack, and you will say this is underflow and you will stop it. Otherwise, what you will do, you will take the value from the stack, you will take the value from the stack, assign it to some variable, and decrement the top variable. What does that mean? It means this is a scenario, this is my stack, I am calling it a stack, and I have the values 2, 3, 4, and top is pointing to the element. And if I say operation pop, pop means you have to take the value which is pointed to by the top. So you do this operation, you will say val equals to stack top. Stack top is what? Stack top means this value. So you will take this value, and top equals to top -1, and top will point to now this. So now this value is out and the top is pointing to this. This is how the things are working. There is another operation that we use in some application, that is called peek operation. The purpose of peek operation is to just have a look what is existing at the top. We are not deleting. So the difference between the peek and pop is, in the peek you simply look to the top value, look to top value of the stack, and pop means take the top value, or you can say remove the top value, or you can say delete the top value. So the difference is, whenever you apply the pop operation, the number of the element will be decreased by 1. So if you have, let's say, 10 elements in the stack, if you apply pop operation, the number of elements will be 9. But in this case, if we have 10 elements in the stack, and if you apply peek operation, it will remain 10, because peek is not going to delete anything, but it will only look to the topmost element of the stack. So if you are trying to look to the top element of the stack, and if the top is null, or you can say the top is -1, then it is said to be empty. You cannot look to any element, and you can say it's simply a empty. Otherwise, what you will do, you will return the value which is actually pointed to by the top variable. So that index need to be returned. This is a peek operation. So these are the three operations. So this is how we can implement the stack using arrays. So let me summarize some more important points. That initially we assume that your top equals to, at initial, when you start working on a stack, top equals to -1. Okay, and in the push we increment top plus plus, and then put the value at the top. This is what we are doing in the push operation. And also in the push we check for the overflow. In the pop, what we are doing, in the pop you take the value from the top, and then you are decrementing the top variable, and you check the underflow. So these are the few points that you have to keep in mind when you are implementing your stack using an array. In the next part, we will see that how to implement the stack using the linked list. Okay, so in this part, we are going to talk about the implementation of the stack using a linked list representation. Already we have seen that how the stack can be implemented using an array. Now, why we want to represent the linked list representation of a stack? Already we have discussed the limitations of array, or you can say the drawbacks of array. To overcome this drawback, we have a linked list representation. Now, what are the drawbacks? The drawback is if you want to use an array, you need to know the size of the array. You need to reserve the memory. But with a linked list, there is no such requirement. So if you are working for any application where you are very much assured about the size which you need for your application, or also if your application is small, then array is good. But if you are working for any uh, real-time application where you are not sure about the size of your input, then in that case linked list will be good option for you, because in the linked list there is no need to reserve the memory. Dynamically you can allocate the memory space for the data that you want to store. Also have a note that the time requirement for the linked list operation in the stack is constant, that is big O of 1. So when we use linked list to implement a stack, we have to create a nodes. Already we have discussed in the linked list discussion that how the linked list can be created. The only thing we need to uh, put some restriction on the linked list operation so that it can behave in the last and first out manner, and it will become the stack. So we'll see how the things will be achieved. Now here we are calling the start pointer of the linked list is at the top. So when we work with the linked list, we have one pointer we are calling as a start, or the head, or the front, which actually points to the first node. Here we will use the term top, which actually points to the first node. Now all the operations uh, of the stack using a linked list are to be done by using the top only, because we have already discussed the property of the stack. Your all the push and pop can be done only at the top. So here you can see if the top equals to null. Now if the top equals to null, that means top does not hold any address. Does not hold any address means there is no node existing, and there is no node existing means that there is no stack created, and you can say that the stack is empty. So you can just have a feel that this is how we have created the linked list. So this is your now if this is top, that means you started from here. You insert the you push the first element, then second element, third element, fourth element, fifth, sixth, seventh, eighth, and this is your last element, because the top is always pointing to the last element. Now one thing you have observed, when I have shown that this is your first you insert 5, then 6, then 2, then 4. So what we actually doing, we are inserting a node at the beginning. That means out of all the operations that we have discussed in the previous lectures, like when we work with the linked list, we have the option to insert a node at the beginning, at the last, or somewhere in the middle. But if you restrict your linked list to only add the node at the beginning, then it actually conforms to the properties of a stack. So you can say that if you only allow to insert at the beginning, that means you are making it push operation, because in the push operation you are only adding a node at the beginning. Okay. Okay, let's talk about the push operation of the stack using a linked list. One thing to keep in mind, this is just a first case that we have discussed already in the linked list, that inserting a node at beginning. So this is insert node at front. We have already discussed how to insert a node at the beginning, at the last, somewhere in between. So if you restrict this condition that the node can be inserted only at the beginning, that means you are able to achieve this LIFO principle, last and first out. So if you insert the node at the front only, that means you conforms to the rule of push of the stack. So insert node at the front is nothing but a push operation. So what is required? The very first thing is you need to create a node. So we create a new node, and then so we created a new node, and we are calling it as a new node, right? That means this is a pointer variable. So when you create this node, the address of this node is stored in this new node variable, right? And this is your new node. You insert the value. This is your data part. You insert the value which you want to store here, and this is your linked part. Now if you want to make this node as a first node, then what is required? So just look here, insert the value in the data part, and we check if data is equals to null. That means this is going to be your first node. Okay, already we have checked. If this is going to be your first node, then in the next part you are going to write null because this is the only node. Okay, and set top equals to new node. So if this is going to be a new node, you have a top, you assign this address new node to top, so that top can point to this node, and also you will assign a null, this is the only node. But if it is not going to be the only node, already the linked list is existing. Let's say this is your scenario. This is your top which points to your first node. Now if this is your new node whose address is with the new node, now if you want to apply the push operation, that means you need to add this node at the beginning. We always insert the node at the beginning because we are only allowed to insert at where the top is pointing. So pointing to the first node. So when you insert it here, now top has to point this new node. Now what is required? Now this is only possible when you are able to connect this node to this node. Means this node should be becoming second node. So what is required? Set new node next is equal to top. So now top is actually holding the address of this node. So if you write this value here, that means now this will point to this node, and set top equals to new node, and to top you will assign this address. So new node is actually pointing to this node. If you write the address of new node, if you write this address at the top, now top will point to this node, and this is what we are looking for. Now top will points to this node, and this node will point to this node, and we have achieved. Already we have discussed the scenario inserting a node at the beginning. So keep in mind, push is nothing but push is just inserting a node at the beginning in the linked list. Now pop operation. This is again delete a node from beginning, from the front. So the very first thing is, whenever we apply the delete operation, we need to check the underflow case. Underflow case means we are checking that your stack is empty or not. Okay, means the linked list is existing or not. Otherwise, what you will do now, scenario is we already have a list. Okay, and this is a scenario. This points to this, this points to this is your last null. We have a top point to this. So when I say pop will always take a node which is pointed to by the top. That means this node we need to delete. So what is required? First you will make one temporary pointer. So ptr will point to this node. So we'll say top equals to ptr, means top is pointing to this node. If you assign the value of top to ptr, now ptr will also point to this node. Okay, now top equals to top next. Now top next means this is your next field, and next field stores the address of this next node. So if I assign top equals to top next equals to top, that means top is now pointing to this node. So top point to this node, and now we want to delete this node. You will say free ptr, or you can say delete ptr. Delete ptr. So this will be deleted, and this is what we are looking for. Now top points to this second node. It becomes first node now, and this is deleted, and we have successfully apply the pop operation. So pop operation means you have to take this value, you have to delete this data, delete this element from the given list. So Keep in mind, whenever we apply the push and pop using a linked list, actually we are doing the addition of node and deletion of node at the front. So this is all about the push and pop operation using a linked list, and it is very easy because already we have discussed a lot about linked list. If you have not uh, uh, watched that video of linked list, I recommend you to first watch the video of linked list operation. Then only you will be able to understand that how the push and pop can be implemented uh, using a linked list. So far we have seen that how the stack can be implemented using a array and using a linked list. Now we will see that what are the applications of stack.